we're going to do encryption using Hill Cipher. So here's our main. So now let's take the key from the user. Hold on. We should make one thing very clear, that we are going to deal with lowercase values only, and there should be no space. So let's filter our inputs. We are having plain text as well that we're going to take from the user, and let's do something to it so that we will automatically make this key and plain text satisfy this condition. Okay, here user enter key, and now we're just lowercasing u. What should I do to make it remove the spaces? I should split it, and I should join it back. So similar thing we can do for the plain text, and let's go. My goodness, I forgot to apply this function join, which will be joining it back to the string. This split will basically split it whenever it will encounter in space. It will split the two strings into list, and it will keep appending whenever it encounters space. It will keep appending that string or substring into the list, and this join function will join back our list to give us a string. So this is what we are doing. Simple thing. We are interested in finding the square root of key because we want to validate if it will be able to form a square matrix or not. Let's go. What should I do? We should use it. We can also use math.floor, but anyways, let's print user fuck off. No, we should be humble. And now you exit. Where is this math? Let's import math. We're done with it. Let's do some validation for plain text. Plain text should be a multiple of n, where n is n cross n matrix is there, so it should be a multiple of n, and if it is not there, then let us append something at the end. So here we go. Let's traverse it for I in range. Let's use something big. That is what I wanted to do. So we are just doing nothing. I will elaborate this logic what I have done here at the end. Explanation 1. Okay, so here we call we make a variable. We are interested in getting the matrix. We have figured out that if it passes this condition successfully, it doesn't run actually, then we are able to form a square matrix. So let's go and make a square matrix of key. But that matrix, let me ask you, should it be invertible or non-invertible? Why do we need the square matrix to be invertible? We will see it later. Let's define this function. So here's our key matrix. We are taking key and n. Let's go and simply let's define a variable that we're going to return at last. So this will be our final result. We are storing everything in it. let's traverse our key, and we are going to form a 2D matrix. So we'll be using 2 loops as usual. Let's make a list. Now let's traverse it again. What should I do? Well, I'm trying to use the concept that is analogous to 2D array in C language you might be familiar with. Otherwise you can do it the way you love. That doesn't matter, doesn't make any difference. So let's append this stamp in our matrix. By this time we have our matrix created. Let me validate if it should be invertible matrix or not, and why it should be invertible matrix. Well, that thing I will be explaining in the decryption part. You will know if we want to decrypt a text that is encrypted using Hill cipher, then it is only possible if our key matrix is square matrix and invertible. So how to find out that? Its determinant simply should not be 0. So let's use NumPy for it. I love NumPy when it comes to tough functions. And if you want to install NumPy, you can use this pip3 install NumPy command. And if you don't have pip3, then bad luck. You should browse the internet and try to install pip3. So let's use it. NumPy dot my favorite linear algebra and determinant of matrix. If it is 0, let's throw an error and kick our user out of the program. Valid key, and let's kick him out by exiting the program. Right. Finally, we are returning our matrix. So by this time we want to check if it is correct or not, and let's do this using matrix. Let's run it. So there is a problem. It is a float. So n is a float. Okay, I figured it out. So please note it that this n out there, here I mean to say, mat.square root will give us, even if it is a square number, if it is 9, then n will be 3.0. But we want integer because we are using n here in the loop. So let's do something. N is equals to mat.floor. We can also use trunk, but let it be. And here I go, addg and blah blah blah. What is it? Key matrix, key matrix. Okay, it's a typo. So addg blah blah blah. What the heck is this? So matrix stamp, matrix dot append. We are going to append the stamp. All right, please run now, otherwise my subscribers will leave me. All right, I don't have any subscribers at this moment, so let's go. It's done. Let's try to check if it is doing something for a non-invertible matrix as well. Invalid key. All right, it's working. Now we have our square matrix, that is key matrix, and now we are interesting. Without any delay, let's make a function that will print our ciphertext, and let it be Hill encrypt, and let us give it plain key, and let's give this not plain. Yeah, plain we can give, it should be a matrix. So let's define this function out there, and we don't need it anymore. Let's go def. So here is our Hill cipher. So we'll be storing everything in this cipher, which should be a string, of course. And now let's traverse it. As I already told you, we will be picking up chunks of n length and inserting them into a column matrix. This is P. Basically, this loop I'm running, why I'm taking this n jump, you'll understand it. Just hold on a little bit. So temp will be multiply matrix our plain text, and I'm slicing it. Okay, all right. So this is it. So this multiply, let me assign it a function, assign it a work. It should return me a multiplication of the matrix key multiplied by our plain text. So plain text, we are taking n length of basically column matrix. I'll elaborate it later on. So this is description 2. Towards the end of the video, I'll be explaining everything. So let's define this function multiply first of all. It will help us to multiply key into plain text, key matrix or plain text. All right. It will be taking x, suppose y, and suppose y is our here we can see its second argument is plain text, so it's a string. We want to convert it back to a list, so we can use it. Jolly moly thing, it should be jolly moly, well, I don't care, for x and y. So here we are having a list. No, it's not a list, it's actually a column matrix, and it's only having integer type column matrix, because we're going to perform multiplication and y was initially a string. We are just converting into a column matrix that will be having positional values of alphabets in string y. Now let's store the result in our result. Let it be a column matrix of len y 1 equals to int. So don't get afraid of it, it's just nothing. You can use simple list to make this thing. Let's do the main stuff. Numpy dot xy. So this is the main thing, and thanks to numpy we don't have to write extra lines of code for it. Return result. So it will return us to temp the result of this multiplication. Now let me run a loop for putting this temp back to cipher, because cipher is a string and it is just a matrix, or I say column matrix, which we get from multiplying key times plain text. So let's go. Because it was a number, we had to convert it. We will keep it 0 because we are just concerned about column matrix, and column matrix always has one column only, so only the row will be changing, as you can see. Let's do some modulo, because we may be getting the result out of the range, and we are working only in the range 0 to 25. So here is our we get ASCII value out of it, and we get our text or the character out of it, and we're just appending it to cipher. So we are finally returning cipher. Let's see if it is working or not. He'll encrypt. My goodness. So this is a key matrix. Let's go. Yeah, it's working. Let's do it. Yeah, it's forming the ciphertext. Now let's go for the explanation. I hope you're able to see it. So we are interested only in explanation of this thing, what I did here. So simply I'll be explaining you it here. So for I in range n minus len plain text %n, it is actually, suppose our key matrix is 3 cross 3 and our plain text is of length say 7. So we will be getting like we are passing this plain text into Hill cipher, Hill encrypt, and that will be encrypting it. And for the process to take place completely, we need to validate that this should be a multiple, this length of plain text should be a multiple of 3, but it is not. We have to add, we can't remove anything from plain text, otherwise it will be lost. It will be of no use. So we are appending x, say x, anything we can append at the end. So we need 2x at the end of this plain text so that it will be of length 9 and we'll be getting this condition satisfied for the multiplication. So for traversing in this range, this n minus len plain n will give me, this is one thing and this is the another thing. So plain n %n modulo n will be giving me, suppose if I'm taking 7 modulo 3, it will give me 1, and n minus 1, which is equal to 2, will giving me the number of x that I need to append. So, and then I am simply using plain plus equals to x. So that's it. Now, second thing that I wanted to explain you is, I hope you're clear with the basic of multiplication of matrices and the basic concept involved in encryption of Hill cipher. I made this video specifically for coding part. What it is going to do, this is our matrix already, a number matrix. This is our plain text, and plain text should be a multiple. Suppose our plain text here we are having, let's consider this example, this real example. So our plain text is attack and our key is say CDDG. So it will be forming a square matrix, 2 by 2 matrix. So we will be taking 2 characters at a time, and if it is not anything out there, then we will be appending x out of it. So this plain text will actually what will it will take this plain 1 to 1 I plus I to I plus n. It will consider this at and pass it to the function multiply. Then this multiply will simply in this multiply we are using this thing. What this line of code is doing, it is converting, it is reading all the characters in the string y, which is this at, and it is converting it back to a list of list. So at is 0 and t is something, say t is 20. I'm assuming it is 20. So it will give us this. What is it? It is just a column matrix. So y will be 0 and this 20, whatever it is. This is our plain text. And our key already, for example, we are having 2, 3, 4, 5. This is our key. And we are having result. So this is it. What will it give? It is 2 cross 2. It is 2 cross 1. This is same. So it will give us 2 cross 1 matrix. And this will be our result. Now this result is coming out there. And now I am traversing through this result for x in range n. As you can see out there, for x in range n, I'm doing this. I'm putting it back to Cipher and returning it. That's it. Thanks a lot.